Hey Valley Metal, welcome back to another math lesson. Today we're going to be solving subtraction equations. Before we do that, let's go ahead and start with our trivia question. Denominations of U.S. currency are currently in circulation today. We'll be back with that after our instructions tonight. Well, officially tonight, our target is I can solve subtraction equations using the inverse operation. Let's dive right into a problem here. Brittany had a bunch of old hockey sticks in her garage. She sold 7 at the family garage sale. Now she has 3 left. Write and solve a one-variable equation. Isolate the variable using the inverse operations. This is just like the process that we went through last night. But last night we had addition equations. Now we have subtraction equations. A subtraction equation, of course, has subtraction in the middle. So in the first couple of lessons of this chapter, we learned how to write these equations. And so now we can safely say that here are the hockey sticks she had. She got rid of 7 of them. She has 3 left. How do we isolate the h? How do we get it by itself by using the inverse operation? Well, the opposite of subtraction is addition, so we add 7 to both sides. Those 7s will cross off. We end up with 3 plus 7 is being equal to h, or h is equal to 10. We've balanced both sides. We've lined up the equal signs, and we put a line underneath the addition to show that now we're rewriting this equation here in a more simplified form. Throw it in, check it. 10 minus 7 is 3, and we are off to the races. Let's take a look at our must-know words tonight. Not much new. We got subtraction equation. That's just an equation where subtraction is the operation, like x minus 2 equals 8, or x minus 3 equals 6. We solve them by isolating the variable and using the inverse operation. So we have subtraction, so we solve with addition. We add 3 to both sides. These guys cross off. We end up with x is equal to 9. So by using the inverse operation, we can isolate the variable. So last night we did addition. They were written with addition. We solved with subtraction. Tonight, they're written with subtraction. We're going to solve with addition. And you can probably guess what the next lessons are going to be. Okay, let's take a look at a couple of problems, and I'll have you try a couple of pause problems. All right, here we have a minus 15 equals 2. Well, subtraction equation, how do we isolate the variable? That's our goal. How do we get rid of minus 15? Well, we're going to add 15 to both sides. If we do that, these 15s will cross off. We have a minus 15 and a plus 15. That leaves nothing but an a. 2 plus 15 is 17. Let's just check our answer. 17 minus 15 equals 2. Let's check our form. Equal signs are lined up. Good. I did the same thing on both sides, not just on one side. Good. And I drew a line underneath to show the separation between the steps of the problem. Thumbs up, duds. All right, let's try one more. Here we go. 78 equals b minus 42. Now I flipped it around a little bit, but we can do this. We still have we have to get rid of this minus 42 to have b by itself. So we add 42 to both sides. The 42s are going to cross off, hopefully. I think I'm going to have to do these by hand. 42s will cross off by themselves. And we're left over here with 78 plus 42, or 120 equals b. Pop it in, see if it works. 78 equals 120 minus 42 every day and all day long in California. All right, 2 pause problems. Let's have you take a look at these. Go ahead and pause the video and isolate the variable, line up the equal signs, draw the line, do everything you're supposed to do. Simple problem. Follow the process. That's right. I don't care about the answer. I just care about the process. Yeah, if I cared about the answer, I'd give you harder numbers. All right. We isolate it by adding 6 to both sides. You end up with, cross those off, make sure you show the cross off, you end up with n equals 30. Check it. 30 minus 6 equals 24. Boom. Done. One more. And we're on to the ticket to the show. All right, let's see how you did. Got to get j by itself, so we're going to have to add 16 to both sides. 40 equals j. See if I forgot to put it on there to cross those guys off, or else I just can't find them very well. There we go. My 16's cross off, and 40 equals j. Double check it. 24 equals 40 minus 16. All day long. All right. Here are your 2 ticket to the show problems. And let's take a look at the trivia question. What denominations of U.S. currency are in circulation today? Well, we've got the 1, 2, 5, 10, 20, 50, and 100. Some interesting things about it. I kind of get into this geeky stuff here. Let's just make this just a touch bigger. Which one of them do not feature a president? Well, he was a statesman, and Benjamin Franklin was, so he wasn't a president. And this is Hamilton. He was I think it was under Lincoln that he was the Secretary of Treasury. He wasn't the president. The rest of them are all presidents. Are there any discontinued currencies? Yes, there are. We used to have a $500 bill with McKinley on it. That baby was history, not in circulation anymore. We also had the $1,000 bill that had Cleveland on it. That one's not in circulation anymore. We even had a $10,000 bill with Chase on it. He was also he was the Secretary of Treasury. Something's fishy about that guy, though. I'm not exactly sure what, but think about it. You'll get it someday. All right. So some of these larger bills, the Federal Reserve started taking them out of circulation, destroying them in 1969. So as of January 14th of this year, there was only 336 $10,000 bills known to exist, along with 342 $5,000 bills, 165,000 roughly 165,000 $1,000 bills. There was also a $100,000 bill, but it was really a gold certificate and never circulated. It was from 1934 to 35. That had Wilson on it. All right. Thanks for listening. Hope you learned something about subtraction equations and also about U.S. currency. See ya.